This is Algebra 1 Review 17 due May 1st, which is this coming Friday. And the test is also due this coming Friday. I'll send attachments for the review and the test that you need to print out and send me pictures when you get them done. Okay, so I'm going to go through one by one, talk about the ones on the review, work them out, show you how to work them, that kind of stuff. So on number 1, on the review, Jim borrows $90 from his parents. They agree to subtract $10 from the loan for each hour he does chores around the house. To find the number of hours X he needs to do chores before he owes less than $50, solve the inequality. So they actually give you this inequality on number 1. That's the last thing they give you, is that right there. So just solve it. So subtract 90 from both sides. You have negative 10x less than negative 40. Then divide by negative 10. So x is greater than 4 because a negative divided by a negative is a positive. A lot of you are saying that a negative divided by a negative is a negative, but this should be positive. Negative divided by a negative is a positive, and we divided across an inequality by a negative, so flip that inequality. So this is your answer. He's got to have more than 4 hours. That's what has to happen for him to owe less than $50. Okay, so that's number 1. Then number 2, it's distributive property with radicals. So you are going to distribute the square root of 2 to 3. So square root of 2 times 3. 3 is not underneath the radical, so that's 3 square roots of 2. Then you're going to distribute the square root of 2 to the square root of 6. They're both underneath the radical, so that's the square root of 12. Then you have to simplify the square root of 12. 2 times 2 times 3. So this would be 2 square roots of 3. So 3 square roots of 2 plus 2 square roots of 3. So that's your answer on number 2. Number 3, you've got the square root of 100, s cubed t squared. So you're going to take it a piece at a time. Square root of 100, square root of s cubed, square root of t squared. So square root of 100 is 10. Square root of t squared is t. Then for this s cubed, you need to break it up into s squared and s. So if I take the square root of s squared, that gives me s. And then the square root of s just stays. So now I've got 10 s square roots of s from this s cubed, and then t. So the 10, the s, and the t on the outside, and then that one s left on the inside. That's the way that one simplifies on number 3. Then on number 4, you've got distributive property to do. You're actually multiplying a binomial times a trinomial. So on number 4, you've got 3x plus 1, and you're multiplying it by negative 2x squared plus 2x plus 4. So then when you distribute 3x times negative 2x squared, negative 6x squared. 3x times 2x is 6x squared. Sorry, let me go back. 3x times 2x squared is 6x cubed. That should be a 6x cubed. And then 3x times 2x is 6x squared. And then 3x times 4 is 12x. Then we get rid of the 3x because we're done with it. Then we multiply everything by 1. So I'd have negative 2x squared. And this is going to take a lot of room now. Negative 2x squared, because 1 times negative 2x squared is negative 2x squared. Then 1 times 2x is 2x. And 1 times 4 is 4. Okay, so right now I've got all of this. Now I combine like terms. Nothing combines with the negative 6x cubed. I've got 6x squared and negative 2x squared, which would be positive 4x squared. And then I've got 12x and 2x, which is 14x. And then plus 4. So that's the distributive property. That's combining like terms. And that's the way you leave it. Don't do anything else. Leave it just like that. Don't factor out anything. Leave it just like that. Okay? So that's number 4. Then on number 5, we're factoring again. Negative 5x cubed minus 10x squared plus 75x. So what you're going to do on this one is you're going to take that negative 5. You can take a 5 out of all of these. You can also take an x out. So you're going to take negative 5x out. That leaves x squared plus 2x, because when I take a negative out, I change the sign, minus 15. because 75 divided by 5 is 15. Now we factor this part, okay? And you need to be careful with this. A lot of you missed your signs on that factoring maze that I sent. A lot of you were missing your signs. It's got to be a negative 15, so your signs have to be different signs, but then you want a positive 2. So that means your bigger factor, because it takes a 5 and a 3 to get the 15 and a 5 and a 3 to get the 2, but you want positive 2, so 5 has to be with the positive. And this is your final answer. You have to make sure you put all three, the negative 5x that we took out, and then the x plus 5x minus 3. So that's number 5. Then on number 6, this is that kind of weird one where we've got that extra y squared in it. So again, we want the factors of negative 10 that give positive 3. And I need an x, I need an x, I need the factors of negative 10 that give positive 3. So it's 5 and 2. It's different signs because that's a negative 10. And we want a positive 3. So that means my 5 goes with the plus, because plus 5 minus 2 we give plus 3. And then I've got to tack a y on because of that y squared. So when I do 5y times 2y, I get that 10y squared. So the y's just kind of follow you along there. But it still works the same. We need the factors of negative 10 that give positive 3. Then on number 7, another factoring one. This one is actually out of order because our x squared isn't first. It's negative 26x plus 8 plus 6x squared. So we've got to put it in the correct order first. So 6x squared minus 26x plus 8. So that's the way it should be written. Now there's a couple of different ways you could do this. You could go ahead and multiply 6 times 8. In fact, I'm going to show both ways, okay? We're going to go and multiply 6 times 8 and you get 48. So I need the factors of 48, of positive 48, that give me negative 26. So they're going to have to both be negatives because I've got to multiply to be a positive and add to be a negative. So negative 24, negative 2. So 6x squared minus 24x minus 2x plus 8. Then we take a 6x out, that's x minus 4. We take a negative 2 out, that's x minus 4. So then we get 6x minus 2, x minus 4. Now, here's the problem with this. It's not completely factored because you can take a 2 out right here. So take a 2 out, get 3x minus 1, x minus 4. Okay, so that's one way to do it. Just multiplying 6 times 8 and going from there. Another way to do it is to take the 2 out first. So let me show that way, just so that you know both ways. Okay, so let me rewrite the 6x squared minus 26x plus 8. So I can take a 2 out and have 3x squared minus 13x plus 4. Okay? Now I take the 3 times the 4 and I get 12. And I need factors of 12 that give me negative 13. So negative 12, negative 1 is what I'd use, because negative 12 times negative 1 is positive 12, and negative 12 plus negative 1 is negative 13. So I rewrite 3x squared minus 12x minus 1x plus 4. So take a 3x out, you get x minus 4. Take a negative 1 out, you get x minus 4. So then 3x minus 1, x minus 4. And here's the problem with you taking the 2 out first. Here's the problem. You forgetting to put it in your final answer. And if you do that, you're going to get it wrong, okay? So make sure that you put all the factors down. Again, on this one, the problem with factoring it this way is that you're not seeing here that a 2 needs to come out. So you've got to make sure you get them completely factored. Make sure you don't leave any extra factors in. Make sure if you take a factor out at the beginning that you put it in your final answer. So be real careful with ones like number 7, okay? Then on number 8, you had one of these on your homework for lesson 83, where you have one leg of a right triangle is twice the length of the other. So one leg of a triangle is twice the length of the other. So we're going to call one leg x and the other leg 2x. So we're going to draw a right triangle. I've got one leg that's x and one leg that's 2x. And this is a right triangle, okay? Then we're given the hypotenuse is 125. So my hypotenuse is the square root of 125. And it tells me let x represent the length of the shorter side. So here's x, here's 2x, and the length of the hypotenuse. Now we want to find the length of the leg. So I've got to find x, okay? So this is what you're going to do. Use Pythagorean theorem. And some of you are not writing your formula for Pythagorean theorem like you're supposed to, so make sure you do that. And then you plug in x squared plus 2x all squared equals the square root of 25 all squared. The square root of 125 all squared. So x squared plus 4x squared, because when I square 2x, it's 4x. And then 125, because the square root of 125 squared is 125. So that'd be 5x squared equals 125. Divide by 5. So x squared is 25. If x squared is 25, x is going to be 5, because I simply take the square root. So that means x is 5 and 2x is 10. And we've got units in centimeters, so we make sure we label the two sides in centimeters. So that's what I want to see on one like number 8. Triangle drawn, labeled x and 2x, use Pythagorean theorem to find x, and then plug back in to find your side lengths. Then on number 9, we want to determine whether it's a Pythagorean triple. So the first thing you have to look at for it to be a Pythagorean triple is whether or not they're whole numbers. Well, you got to have 3. Sorry. We've got 3. They're all whole numbers, so we check them. And a squared plus b squared equals c squared. Again, you're using this formula, so make sure you write it. So 12 squared plus 16 squared, does that equal 20 squared? Well, 12 squared is 144. 16 squared, let me just make sure I check my math before I mess up, is 256. And then 20 squared is 400. So we add 144 and 256, and we get 400. So there you go. So it's yes. Make sure you put yes. It is a Pythagorean triple. It is a pi trie. Then on number 10, you're subtracting a square roots of 2a minus the square root of 8a cubed. So this kind of takes us back to number 3, where we've got to simplify. This one's already simplified. I can't do anything with the 2a. Okay, so I'm just going to rewrite that. What I want to try to do is get this simplified so that I can combine the two. So I want to do the square root of 8 and the square root of a cubed. 8 is 2 times 2 times 2, so that's 2 square roots of 2. A cubed is a squared times a, so if I take the square root of that, that'd be a square roots of a. So when I put these together, the 2 and the a on the outside stay together, and the 2 and the a on the inside stay together. So that's how it simplifies. So I've got a square roots of 2a minus 2a square roots of 2a. Well, they're like terms. They both have a square root of 2a, and they both have an a. So this is 1a minus 2a would give negative a, or negative 1a, square roots of 2a. We just leave that square root of 2a like it is. Okay, so that's number 10. Then number 11, looks like we are varying inversely on number 11. So if we vary inversely on number 11, that's x1, y1 equals x2, y2. That's how we write varies inversely. Y is 8, our first y is 8, our first x is 13. We want the second x when y is 26. So then right here, just divide by 26. And then you can type that in your calculator, 13 times 8 divided by 26. I know 13 goes into 26 and leaves a 2, and 8 divided by 2 is 4. Or again, you can do 13 times 8 divided by 26, you're going to get 4. But that's the way you work with the varies inversely like number 11. Then on number 12, we want to see, we're asked to decide if it's a perfect square trinomial, x squared minus 24x plus 144. So let me remind you how you decide if it's a perfect square trinomial. First, it's got to be a trinomial. Does it have 3 terms? Yes. So it is a trinomial. Now, for a perfect square trinomial, the first one has to have a square root, which it does. It's x. The last one also has to have a square root. It does. It's 12. The middle term, you have to multiply x times 12 and get 12x, and then double it. Is 2 times 12, 24? Yes. Don't worry about the sign. Is 2 times 12, 24? Yes. So this is a perfect square trinomial. So it factors into x minus 12 all squared, because you take the square root, and you take that sign into the factoring, and it's got to factor as a binomial squared. So then you'd put PST, because it is a perfect square trinomial. And that's the reason we can factor it that way. So that's the way you decide if it's a perfect square trinomial, and that's the way you factor that perfect square trinomial. Then on number 13, we've got this 100x to the 8th plus 2,000x to the 7th plus 10,000x to the 6th. Okay, let me make sure I've got that written correctly, and let me get rid of the glare. So 100x to the 8th, 2000x to the 7th, and 10,000x to the 6th. So the length of the hypotenuse of a right triangle is found by adding the squares of the two legs and then taking the square root. Find the sum of the squares of the legs is shown below. Find the length of the hypotenuse. Okay, so we want to factor this. Okay, so I can take a 100 out of every one of these. I can also take an x to the 6th. I can take an x to the 6th here. I can take an x to the 6th out of this one and an x to the 6th out of this one. And it's going to leave me something that factors easily. X squared plus 20x plus 100. Now, this is a perfect square trinomial. How do I know? Square root, find the product of the two 10x, double it, I get 20. So this factors into x plus 10 all squared. So I've got 100 x to the 6th times x plus 10 all squared. Okay? This is what I've got now. Now, we're told to take the square root. We want to find the length of the hypotenuse. So you're going to take the square root of this. So the square root of 100 is 10. The square root of x to the 6 is x cubed. And the square root of x plus 10 squared is just x plus 10. Okay? Now again, if I went over that a little too fast, go over it again. Start the video again, rewind, watch it again. You're factoring it. You're going to get a perfect square trinomial, so factor it into a binomial squared like we did on 12 and here. And then you take the square root. It's going to be easy to take the square root. This is going to have a perfect, this is going to be a perfect square. Everything's going to be a perfect square. So just cut your exponents in half. We cut 6 in half, we cut 2 in half, and then take the square root of 100, which is 10. Okay? So that's number 13. Then on number 14, you're solving a disjunction. And solving a disjunction is basically just solving two different inequalities in the same problem, like on the same number, okay? So there's that. So you're going to subtract 6 first, and you've got negative x less than negative 21, and you're going to divide by negative 1. So x is greater than 21, because you got to flip that inequality, okay? Or, which so many of y'all forget to write the ors when you're solving these disjunctions. Do not forget to write the or, okay? Then we add 4 here. So 3x is greater than or equal to 12. Divide by 3. So x is greater than or equal to 4. So here's my answer. It does not have to be graphed. So don't graph it, because this is a weird disjunction, okay? So don't graph this disjunction because you're not asked to. You're just asked to solve it. So we solve it and we're done, okay? Then on number 15, we're writing a polynomial in standard form. So my polynomial starts out like this: 4a cubed plus a to the 5th plus 5a to the 4th. So, and then I want to find the lead coefficient. So to write it in standard form, I put my biggest exponent first, or my term with the biggest degree first, and then the degrees go down from there. So I've got a to the 5th, a to the 4th, a cubed, and it will go down from there, okay? Then if you want your lead coefficient, it's the first coefficient, which on this one is 1. A to the 5th is not the coefficient, and 5 is not the coefficient. 5 is the exponent. A to the 5th is the term. The coefficient is the number in front of the a, which here would be an understood 1. So your lead coefficient is 1 on number 15. Then on number 16, we are supposed to determine whether these lines are parallel. So the first line is y equals 5 over 3x minus 1. The second line is 5x minus 3y equals negative 3. The easiest way to tell whether two lines are parallel is to look at the slope. So on the first one, slope is obvious. There's the slope right there. Second one, I can't find the slope. I can't see the slope right now because y is not by itself. So we go ahead and we subtract 5x. We need to get y by itself. We divide everything by negative 3, so y equals 1 plus 5x over 3. Now here's my slope. Parallel lines have the same slope, so yes, these are parallel. Perpendicular lines, remember, have opposite reciprocal slopes. So let me show you what opposite reciprocal slope. So let me show you. If this was 5 over 3, then perpendicular would be negative 3 over 5. Okay, that's just FYI, because on the test, it may be parallel, it may be perpendicular. Okay, so parallel lines have the same slope, so these are parallel. These are parallel. But then don't forget about perpendicular. Perpendicular have opposite reciprocal slopes. 5 over 3, perpendicular would be negative 3 over 5. So that's number 16. Then on number 17, solving another inequality, and I'm pretty sure on 17 we've got to graph it. So 17 has to be graphed, so make sure you do it all. So on the test, make sure you read carefully. Graph the one that needs to be graphed. If it doesn't need to be graphed, don't graph it. So we subtract 2x from both sides, so negative 5x minus 8 greater than 2. Then I add 8 to both sides, so negative 5x greater than 10. Divide by negative 5. I'm dividing across an inequality by a negative, so I flip the inequality. So x is less than negative 2. So open circle on negative 2, shading to the left. Now, some of you are not being careful at all when you do your graph. You're either not putting the number on your graph or you're not putting the correct number. Like if this is a negative 2, you're putting a positive 2. If it needs an open circle, you're putting a closed circle. So be careful on your graph because you're missing these for silly reasons. You shouldn't miss it because you've got a negative 2 here and you put a positive 2 on the graph. But I will mark it wrong. One, because you're using your review on the test and you have a long time to do the test. So it's not like it's timed where you have to rush through. So you need to make sure that you get every little piece right. So take your time, use your review on the test like you're supposed to so that you don't make those silly mistakes. 18 is another one where you're solving and graphing. This is actually a conjunction because I've got x between two numbers. I've got this x, that 3x and 3x between the negative 11 and the 7. So this is written as a conjunction. So what we're going to do is we're going to combine like terms here. So negative 11 less than or equal to 6x minus 5 less than or equal to 7. Add 5 to both sides. Add 5 to everything, actually. We've got to add it to the negative 11 as well. So negative 6 less than or equal to 6x less than or equal to 12. And then we're going to divide everything by 6, every piece by 6. So negative 1 less than or equal to x less than or equal to 2. And it has to be graphed. So negative 1, 2, close circles between, close circles on them, and then you shade in between. So that's what I want to see. I want to see that right there. Then on number 19, we are trying to decide whether these ordered pairs are direct variation or not. And we want to find the constant of variation. We're asked to find the constant of variation. So first, what we do, if we want it to be direct variation, the constant of variation is found by dividing y by x. So 15 over negative 5, that's negative 3. Negative 10 over 5, that's negative 2. Negative 7 over 2 is negative 7 over 2. These do not equal. So this is not direct variation. If they were the same number, like if they all came out to be negative 3, then it'd be yes, it is direct variation. Or if they all came out to be negative 2, yes, it's direct variation. Or if they all came out to be negative 7 over 2, then yes, it's direct variation. But this is how you find it. For direct variation, your k is y over x, so you solve it this way, okay? And then if they match, it is. If they don't match, it's not. And then the last one on the review is number 20. Number 20, a penny is dropped from a 284-foot tall tower. The equation 284 minus h equals 16t squared can be used to find the height h of a penny after falling for t seconds. Estimate the height in feet of the penny after 2 seconds. So they're giving you the time. T is 2. T stands for time. They tell you it's 2 seconds. So your t is 2. So 284 minus h equals 16 times 2 squared. Then you go from there. 284 minus h equals 16 times 4 because PEMDAS, remember order of operations, you do exponents before you multiply. So that would be 64. So 284 minus h, subtract 284. So negative h equals negative 220, which we can't have a negative height, which is fine because we've got a negative h. So change both signs, divide by negative 1, so 220 feet. Make sure you put feet. And that's how you find the height. And that's the review, number 17. Again, it's due May 1st. this Friday, and that's when the test is due, May 1st, this Friday.